In sports, announcer says that the team has the momentum when they score points after points, and the opposing team is having great difficulty making a counterattack. We can say that the winning team is on the move. To stop their momentum, the other's team coach usually calls for a timeout. In some way, we can relate this to how momentum is specifically defined in physics. In physics, momentum is defined as the product of mass and velocity. So, an object that is both moving very fast and has a huge mass would have a large momentum, and it would be difficult to stop its motion. If, for example, a truck and a bicycle is moving at the same speed, it would be easier to stop the bicycle from its track due to the large momentum of the truck. However, a speeding bullet would also have a high momentum despite having little mass. Remember that momentum depends on two variables, mass and velocity. Force is needed to increase the velocity of an object and therefore its momentum. If a cyclist pedaled twice as hard, this causes twice the pushing force on the bike, leading to an increase in momentum. If the pushing force is applied over a longer period of time, the momentum is further increased. Of course, force is also needed to decrease or stop the velocity of an object. If a biker wants his bike to slow down, he would press the brake handles, causing the brake pads to squeeze the tire disc. The squeezing force can be sustained for a long period of time, making the bike stop eventually. These two examples show us that applying force over a period of time on an object will lead to a change in its momentum. The product of force and time is another concept we will discuss here, and that is called impulse. Impulse causes change in momentum. To be exact, the change in momentum an object will experience is equal to the impulse exerted on the said object. In equation form, we can show the relationship of the two this way. Mass times change in velocity is equal to the product of force times time. The unit of momentum is kilogram meter per second, while that of impulse is Newton seconds. Going back to the equation, an impulse of 5 Newton seconds will cause an increase or decrease in momentum of 5 kilogram meter per second. Let's use a visual diagram to make the relationship between the four variables even more apparent. Here we have two rectangles of equal size, one representing the momentum change and the other the impulse. Momentum change depends on two variables, mass and change in velocity, which we will represent as the green and yellow boxes inside the momentum rectangle. More green boxes mean that mass contributes more to the momentum of the object rather than velocity. Meanwhile, the other equally sized rectangle represents impulse. Insides are blue and purple boxes to represent how force and time contributes to its value respectively. If, for example, you want to increase the momentum of an object, what would you do? Well, you can do this by exerting greater impulse on the said object. For example, a batter who wants to hit a home run would use the technique called follow up the ball. Aside from hitting the ball as hard as they could, they would also follow up by keeping the ball in contact with the bat as long as possible. Hence, both force and time is increased, thereby increasing momentum. But what if you want to decrease an object's momentum or bring it to zero? How would you do it? Let's say you have a choice to throw an egg on a wall or to catch it using a blanket. If you want to save the egg from breaking, you would obviously use a blanket to do so. But how does impulse and momentum explain this? Stopping the motion of the egg using either a wall or a blanket result to the same change in momentum. the egg will be brought to a zero velocity after the impact just the same. This also means that it would take the same impulse from the wall or the blanket to do so. And by impulse, we don't simply mean force, we mean the product of force and time. Going back to our visual diagram, we can see that we can provide this impulse in two ways. Either we stop the momentum by exerting a large force over a short period of time, or we can prolong the time of impact, thereby decreasing the impact force. In hitting the egg on the wall, the change in momentum happens very swiftly, but the blanket has some give or stretch to it, allowing the time of contact to be prolonged. If we can increase the time it takes for the momentum to be brought to zero, you will reduce the force needed to do it. This same principle is why airbags and seatbelts are installed in cars. A speeding car has high momentum, and if there's a need to hit the brake suddenly, it would require a huge amount of force to stop it. This stopping force can come from the hard windshield or the steering wheel, which can be detrimental to the driver's life. However, if the driver is wearing a seatbelt and the car's airbag successfully deployed, the driver's body would hit them instead, dissipating the kinetic energy by prolonging the time of impact. This is the same reason why floor mats are placed for acrobats and gymnasts during their routine. When you jump from an elevated position, we instinctively bend our knees to prolong the contact with the ground. Otherwise, we would hurt our knees. If you are catching a fast baseball, you would extend your hands forward so that they would have plenty of room to move backward after you make contact with the ball. Other athletes who make use of these principles are boxers. When receiving a punch, these athletes ride the punch. Instead of stiffening their neck and receiving the blow full ahead, they would move their neck into the direction of the punch. The prolonged impact time would lessen the impact force. To summarize, momentum is the product of mass and velocity. Fast moving and heavy objects has high momentum. To bring an object's momentum to zero, impulse can be exerted. Impulse is the product of force and time. If the body's momentum is needed to be reduced, impact force is decreased by prolonging contact time to avoid injuries.